All right, number 13, we got a hexagonal prism 6 feet tall with a regular base. So the regular base indicates that all the lengths of the hexagon are the same length. So let's see, 9 feet on each edge of that hexagon. So let me start with the hexagon actually, and I'll try to do this three-dimensional as best I can. So there's a hexagon. I don't know how regular it is, but I think it'll work. Six-sided shape for a hexagon. So let's go and just pile this up like that. And again, this is the start of our hexagonal prism. So yeah, all we gotta do now is just connect the edges together. And I guess I am kind of leaving a little space right there so that we can tell the difference of the two sides that we're looking at. Six-sided figure. And then, of course, we need to see if I can clean that up just a little bit. There we go. That's not my worst work right there. And that sets up our hexagonal prism right here. And let's go ahead and start measuring or putting down some of these measurements. So we know it's 6 feet tall. Well, that would be the height right here at 6 feet. And of course, that's all of the heights along the edges, which is going to help us with the lateral surface area. And then each of the lengths of the edges of the hexagonal prism is 9 feet. So that would be all of these that make up the hexagon. So this is a 9-foot edge right there. And then we have an apothem at 7.8 feet. So that, again, that goes from the center to the edge at 90 degrees. Okay? Well, that length is 7.8 feet along there. Okay? So having drawn this, then hopefully this will help us to kind of figure out the rest of it. If I'm looking at a hexagon six-sided shape like this, we can put the apothem on this at 7.8 feet. And again, we do know that each of the edges is at 9 feet, like this. Okay. So when I want to figure out the triangle, which I do need, the area of one of them, of course there will be 6 total triangles, all matching. And this would match if I had drawn that a little better, of course. But I need to find the area of just one of those triangles. So that would be like taking the height, that's 7.8 feet, multiplying it by 9. And again, we just need to divide that by 2. Again, I showed that a little different. I hope that's okay. 7.8 times 9 divided by 2. And I get that the area of one of those triangles is 35.1 square feet. Of course, there's 6 of those triangles there, so I need to multiply that by 6 to get 210.6 square feet. And again, that's just one of these hexagons. We do have 2 of them, though. So I do need to multiply that by 2. And that gives me 421.2 square feet. That would be the area of both of the hexagons. Okay? So that's a really good start right there. Now, the other shape that we have is the rectangles. Okay? So something like this. And I'm trying to color coordinate these so that we know that purple is 6 feet, and then the red is 9 feet right there. We do want the area of that full rectangle. So the area of that rectangle would be 6 times 9. Well, that's just 54 square feet. And how many of those rectangles are there? Well, there's 6 going all the way around. I got 1, 2, 3, 4, 5, and then 6 right there. Okay? So we need to multiply the 54 by 6. That will give us the lateral surface area, by the way, which is 324 square units. That's a Q, square units. So that's our lateral area. And that would be one of the answers for the assignment. But we need to add the 421.2 square units to figure out the total surface area. So the final total surface area, 324 plus 421.2, and I get 745.2. Again, that's in square units. Not units, I apologize. This is in feet, right? We do know the units on this one. Square feet. So yeah, the lateral surface area also in square feet. And that completes the problem.